All right. Hi everyone. So my name is Paul. I'm not Lachlan, but I'll give a bit of a. He's not here. He's not available to be here today. But I thought I'd give a brief summary of what he did. So he also looked at the race data, speed, stroke rate, and stroke distance. And I guess the difference is he focused on this particular indices that could be used to analyze this. So speed is determined by stroke distance. And he looked into previous research, has sought to discover an appropriate indexing concept to quantify this relationship between speed and race time. So he looked at effective work per stroke and evaluating that. So he focused on evaluating indices using race data and look at the relationship between different variables in aquatic locomotion defined by factors like the mean speed, stroke rate, and stroke distance. Index is a compound measure that aggregates multiple indicators. So some of the indices he looked at, so a simple one was the product of the speed and stroke distance that he found had a limited ability and poor performance as an index in terms of its predictive power. He also looked at the effective work per stroke, which was a biomechanically derived index, and probably pretty safe to say that people in this room would know this much better than I would. So this one, can I zoom in? Yes, excellent. The work per stroke as a percentage is this function of the VIs, the actual velocity in that segment, subtract the modeled velocity Vn, and so taking that as a ratio, where the modeled velocity is some baseline velocity times the stroke rate, so the modeled stroke rate to the baseline raised to the power of a third. So he looked at the similar data set, 100-meter female freestyle events, 3 athletes, 5 to 7 races per athlete. The variables looked at included block time, free swim time, turn index, and so on. And also, so what he actually used, though, was he looked just at the free swim segments and analyzed stroke rate and stroke distance. Looking at the race as a whole and also the individual segments. So that was the two different analyses. So he also applied stepwise regression to look at one of the most significant variables. And let's see, he found average stroke rate and the average distance per stroke were very highly significant. Interestingly, the coefficient for the distance per stroke in terms of predicting velocity, was it? I think. It had a much higher impact than average stroke rate. Plot the residuals as before. I won't go into the details of this. This is for in these plots. I'll try to zoom in again. Lachlan looked at the 2 different indices, the effective work per stroke as well as the distance per stroke. This is across 7 races, and this is the average value of those indices for each of these races. And I guess the interesting part is, well, how do they vary between them? So a negative effective work per stroke, and its relationship to distance per stroke versus a highly positive one. And so that's kind of what he's plotting here, the kind of the change in the as you go further into the race season, I guess, the effective work per stroke kind of declines. So the effective work per stroke was correlated to race performance, with the fastest race having the highest effective work per stroke and the lowest stroke rate, and with slower races having low effectiveness and high stroke rate. Effective work per stroke was reduced in a race as the swimmer fatigued, and the within race standard deviation effectiveness was low in fast swims. So there's strong correlation between effectiveness profile and swim speed. It is important to maintain effectiveness throughout the race. So basically, EWPS seemed to be a promising index for this kind of analysis. I believe that's it. Does anyone have any questions or any follow-ups?
Baseline stroke rates and velocities, where do they come from? How do you calculate those?
I actually have to check with Lachlan.
Yeah.
I can't remember. Cool. How was that?
100 meters.
Yeah.
100 meters. Yeah, 100 meters.
And 100 meters, the stroke is more important than the stroke rate.
It's a balance. So if you go for 3 meters, your score is many, you're not going to be able to go fast enough. Because to do that, you're going to have to sit in too high gear. It just depends on the individual, but probably within an individual, they're going to go at a faster velocity for the same stroke rate when they're fresh. So that's probably the effect you see rather than